there, what's going on? We got another short little lesson for you today. 1.5, we're going to do some problem solving. It's going to look scary because there's going to be oh so many words. Lots of words. Oh, look at all the words. There's words and words and words, and there's numbers in there with the words, but it will be okay. We just need to take our time and figure things out. So a lot of this is going to be based on things that are similar to our slope-intercept form where we've got the y equals mx plus b. We still haven't actually talked about in class, but you should know. We're going to make things kind of look like that. Slope. Slope doesn't just mean a line that goes up, rise over, run. Slope also is just a rate of change. Anything that is changing per day, per hour, per person, $6 a minute, 4 cents per text, back before everybody had unlimited texting, all kinds of things. There's what is it, a number of characters per tweet that you're allowed. Look at that. Anytime you got that, that's talking about a rate, how many things per something else for each one. So those are kind of like our slope. Our intercept, that is the more constant thing. It just stays there. That's things that are like flat fees. They are stuff that do not change. You just pay it no matter what. Or it is a constant that isn't going to change based on numbers from other things. So a nice good question here if you're visiting Baltimore, which if you've ever watched the show The Wire, I love that show. Doesn't seem like a place you want to go visit, but in any case, we're going to Baltimore. Taxi company there is charging a flat fee of $3. Hey, $3. There's my flat fee. And an additional 75 cents per mile. What is that rate then? That is 0.75 per mile. Alright, let C represent our total cost and X represent the number of miles. Write a model. Alright, whenever it says C equals our total cost, that's always going to be our C equals. X is our number of miles. Now which one of these matters for miles? Well, it's going to be the one that says per mile. For every mile that we go in the taxi, we're going to pay 75 cents. So that's going to be the one that multiplies by the X. I'm going to write 0.75X right there, because for every mile that we drive, we're going to multiply it by 0.75 because that's how much it costs per mile. The most important word that you're going to find inside any of these problems is the per. Now lastly, you pay that $3 as soon as you sit down in there no matter where you go, so we add that at the end, plus 3. So our cost of the taxi is 75 cents per mile X, plus our $3 fee for just getting in there. Alright, example number 2 here. This one's kind of a crazy, weird, long story, but in 1960, the average lifespan of an American woman was 73 years. So the average person born around that time was going to live supposedly 73 years. Ever since then, the lifespan has been increasing by 0.2 years. That's nice. Why is that? Probably because we're getting better at medicine and stuff, solving cancer and curing AIDS and all kinds of things that we're doing these days to keep people alive longer, despite the disgusting food that we eat. Alright, so A is going to represent our average lifespan. A. Which one of these two things, this number or this number, seems like the one that is going to go up or down based on how many years? Well, the lifespan for an American woman has increased by 0.2 years for every year since then. Well, that's going to be our multiply number then. 0.2 times, I think it says T, the number of years, plus 73, because that was where we started from. Whoa, that's a disgustingly bad 3. So, our average lifespan of the woman is going from 73 years plus 0.2 for every year since then. I think you should use this formula and decide how long is it going to be that you should live based on the average American woman's lifespan. Or don't. It might be sad. Who wants to think about themselves not being around anymore? Example number 3. Oh, man. This pen is giving me crazy stuff. Plumber's going to charge a fee of $50 to make a house call. So that means once your plumber comes out there, you're going to pay $50 no matter what. He also is going to charge $25 per hour for labor. $25 per hour. Hour is H. So $25 times every hour he is there, plus $50 for showing up. There's your model. Look how easy that is. Again, most important word here is the per. Per means multiply. And one of the questions that they've had on the test before. Cost of parts to repair a car is that much money. Oh, goodness. This sucks. The cost of labor was $70 per hour. Per, that means multiply. That means I want my 70 to be multiplying that. Now the difference between these two is whether we're going to add in the cost of the parts or subtract it. Think about it. When you go and get your car fixed, are they going to add that to your bill, or are they going to say, nah, man, not only are we not going to charge you for the parts, we're going to pay you for the parts? That ain't going to happen. So we're going to go with A here. $70 per hour plus the $1,000 for all of the parts. And look at that. Little 6 minutes and we are done with story problems based on our linear model. Alright, well, I hope you're going to enjoy some examples of these in class. I think we might even make you write your own. It'll be fun. In any case, make some good choices in your lives, and we'll see you back at school.